Hello everyone. In this session of CCNA series, I'll discuss about different types of IPv6 address. There are three major categories of IPv6 address: unicast, multicast, and anycast. If you remember, the types of network communication in IPv4 are unicast, multicast, and broadcast. So there is no broadcast in IPv6. Unicast is a term Unicast is a term used to describe communication where a piece of information is sent from one point to another point. Unicast is a one-to-one type of network communication. In this case, there is just one sender and one receiver. For example, let's take browsing a website where web server is the sender and your computer is the receiver. Multicast. Multicast is a term used to describe communication where a piece of information is sent from one point to a set of other points. Multicast is a type of communication where multicast traffic addressed for a group of devices on the network. IPv6 multicast traffic are sent to a group and only members of that group receive the multicast traffic. In this case, there is maybe one sender and the information is distributed to a set of receiver. For example, let's take TV channels. The multicast server generates only one stream of data and that stream is replicated to different devices who are interested in that data traffic. Anycast. Anycast is a type of IPv6 network communication in which IPv6 datagrams from a source are routed to the nearest device in terms of routing distance from a group of servers which provide the same service. Anycast, also known as IP Anycast, is a networking technique that allows for multiple machines to share the same IP addresses. Every node which provide the same service are configured with same Anycast destination address. Based on the location of the user request, the router sends it to the machine in the network that is closest. Let's discuss each categories in more details, starting with IPv6 unicast address. Unicast address represents a single interface. Packets addressed to the unicast address will be delivered to a specific network interface. There are three types of IPv6 unicast address: global unicast, unique local or site local, and link local. IPv6 global unicast address is similar to a public IPv4 address. These are globally unique internet routable addresses. Currently, IANA has assigned only 2000:3 addresses to the global pool. The organization that needs IPv6 address asks for the registered IPv6 address block, which is assigned as a global routing prefix. Both the IPv6 and IPv4 address assignment process rely on the same organizations, IANA along with ICANN, the Regional Internet Registry, RIR, and the ISPs. For example, an imaginary organization or a company needs a prefix. The address assignment process is as follows. First step, IANA allocates ARIN, prefix 2001:16. ARIN, the RIR for North America, asks IANA for the allocation of a large block of addresses. In this imaginary example, IANA gives ARIN a prefix of all address that begins with 2001 or 2001:16. Step 2. ARIN allocates North American ISP1 prefix 2001:0db8:32. That is, North American ISP1, an imaginary ISP based on North America, asks ARIN for a new IPv6 prefix. ARIN takes a subset of its 2001:16 prefix, specifically all addresses that begin with 32 bits, that is 8 hex digits, 2001:0db8, and allocates it to the ISP. Step 3. North American ISP1 assigns Company 1 2001:0db8 41:48. Company 1 decides to start supporting IPv6, so it goes to its ISP North American ISP1 to ask for a block of global unicast address. North American ISP1 assigns Company 1 a small piece of North American ISP1's address block. In this case, the address that begins with 48 bits, 12 hex digits of 2001 0db8 4 times 1 double colon slash 48. Let's look at the generic structure of the global unicast address, which has three fields, starting with global routing prefix. The global routing prefix is the prefix or network portion of the address assigned by the provider, such as an internet service provider, to the customer site. Subnet ID is a separate field for allocating subnets within the customer site. Unlike with IPv4, it is not necessary to borrow bits from the host portion to create subnets. The number of bits in the subnet falls between the global routing prefix ends and where the interface ID or host portion begins. This makes subnetting simple and manageable. The last one we have is interface ID or host ID, which identifies the interface on the subnet equivalent to the host portion of the IPv4 address. The host portion is in most cases 64-bit. Next, we have unique local addresses, which are also known as private IPv6 addresses or local IPv6 addresses. Unique local addresses can be used similarly to global unicast address but are for private use and should not be routed in the global internet. Unique local addresses have the similar function as IPv4 private addresses. They are not allocated by an address registry and are not meant to be routed outside their domain. Unique local addresses are only to be used in more limited area, such as within a site or routed between a limited number of administrative domains. Unique local addresses are for devices that never need access to the internet and never need to be accessible from the internet. Unique local addresses have the prefix FC00:7, which results in the range of addresses from FC00:7 to FDFF:7. Next, let's look at link local. IPv6 uses link local addresses as a special kind of unicast IPv6 address. Link local addresses are confined to a single link. Link local addresses are used to communicate with other devices on the same local link. With IPv6, the term link refers to a subnet. Their uniqueness must only be confirmed on that link because they are not routable beyond the link. Therefore, routers do not forward packets with a link local address. Devices can use duplicate address detection (DAD) to determine whether or not the link local address is unique. Link local addresses have a prefix of FE80:10. The following are some of the ways IPv6 devices use a link local addresses. Like when a device starts up, before it obtains a global unicast address, the device uses its IPv6 link local address as its source address to communicate with other devices on the network, including the local router. Devices uses the router link local addresses as their default gateway address. Routers exchange IPv6 dynamic routing protocol such as OSPF version 3, EIGRP for IPv6, and RIP-NG messages for their IPv6 link local addresses. IPv6 routing table entries populated from dynamic routing protocol use the IPv6 link local address as the next hop address. They are also mostly used for auto address configuration and neighbor discovery. The next category or type of address we have is multicast address in IPv6, which are similar to multicast address in IPv4. They are used to communicate with dynamic groupings of hosts. An IPv6 multicast address defines a group of devices known as multicast group. IPv6 multicast address uses the prefix FF00:8, which is equivalent to the IPv4 multicast address 224.0.0.0/4. A packet sent to a multicast group always has a unicast source address. A multicast address can never be the source address. Unlike IPv4, there is no broadcast address in IPv6. Some of the well-known multicast addresses have the prefix FF00:12. Some examples of IPv6 well-known multicast address include the following: FF02:1 all IPv6 devices, FF02:2 all IPv6 routers, FF02:5 all OSPF version 3 routers, FF02:A all EIGRP IPv6 router. And the last one we have is Anycast address. The last type of IPv6 address examined in this chapter will be Anycast address. An IPv6 Anycast address is an address that can be assigned to more than one device. In other words, multiple devices can have the same Anycast address. A packet sent to an Anycast address is routed to the nearest interface having that address, according to the router's routing table. There is no special prefix for an IPv6 Anycast address. An IPv6 Anycast address uses the same address range as global unicast address. For example, 3 servers in the figure could be a DHCP v6 servers with direct layer 3 communication into the network. These servers could advertise the same /128 address using OSPF version 3. The router nearest to the client request would then forward packets to the nearest server identified in the routing table. That's it for this session. Thank you for watching.